Hello Year 11s, this is the refinement of June 2018 paper 2 and it's the second half of that paper. You should only be watching this video if you are in alpha or in beta. We're refining in blue pen. The graphs of y against x represent 4 different types of proportionality. Match each type of proportionality in the table to the correct graph. You can see I've got y is proportional to x, which means y equals kx, so that would be a straight line with positive gradient. Y equals kx squared, so that would be a positive quadratic. Y equals the square root of x, or proportional to, I'm going to come back to that one, I'm not so comfortable with that one, and y is equal to k over x, which I know is a reciprocal graph which looks like this. So I'm going to see if I can find those three and then hopefully I'll be left with the one for the square root. Let's start with the straight line. I can see that must be b, that's the only one with a straight line. X squared, this looks like it's come from like a positive quadratic, so that must be d. Coming back to that one. And then this one looks like it's come from, if I extended the axes, this graph, so that must be C, so this one must be A. B, D, A, C. You would get 1 mark if you had at least 2 correct, and 2 marks for all 4 correct. Question 13. A, B, C and D are points on the circumference of a circle centre O. F, D, E is a tangent to the circle. Show that y minus x is equal to 90. Give a reason for each stage of your working. This is a circle theorem question, and I think we will actually need quite a few circle theorems for this. I am going to go through it, but this is something that we will cover around Christmas time. You'll learn circle theorems. So the first thing I can see is a cyclic quadrilateral. I know opposite angles in a cyclic quadrilateral sum to 180, so this must be 180 minus y. I'm going to make a little note for my reasons. The reason for that is opposite angles in a cyclic quadrilateral sum to 180. What else can I see? I can see a tangent and a triangle, so I can see some alternate segment theorem, and I can see this triangle and the tangent, which means that this angle is the same as this one. These two angles are the same. So this angle must be 180 minus y. I'm going to put my reason, which is just alternate segment theorem. What else can I see? I can also see a radius and a tangent meeting, which means that this whole angle must be 90 degrees. I'm going to get this in big. I'll put a little 3. The reason is that a radius and tangent meet at 90 degrees. And then finally I could work out the size of x. If this whole angle is 90 and this bit of the angle is 180 minus y, then x must equal 90 subtract 180 minus y, which is 90 minus 180 plus y. So x is negative 90 plus y. And I'm almost here. I just need to subtract x on both sides and add 90 on both sides. It's going to leave me with 90 equals y subtract x. which is the thing they asked me to prove. You would get 1 mark for any of these angles if you had this as 90, or if you had this as 180 minus y, that would be 1 mark. 1 mark for a complete method leading to y minus x equals 90, so just the kind of numbers and algebra bits, no reasons needed to get that mark. And then 1 mark for all of the reasons linked to your workings out. Part B. Dylan was asked to give some possible values for x and y. He said y could be 200 and x could be 110 because 200 minus 110 equals 90. Is Dylan correct? You must give a reason for your answer. I can see that, especially for x, x needs to be less than 90 because this whole angle is 90. So x needs to be less than 90. So 110 for x cannot be right. So no, x must be less than 90 degrees. See, there's another option, which is you could say no, as y must be less than 180 degrees as it's in a triangle. Is another way you could get the mark for that. Question 14. The distance time graph shows information about part of a car journey. Use the graph to estimate the speed of the car at 5 seconds. Speed, I know from my core knowledge, is distance divided by time. I can see I've got distance on the y-axis and I've got time on the x-axis, so I'm doing kind of like y over x, which is making me think of change in y over change in x. It's making me think of gradient. So I think for this question I need to find the gradient of the curve at 5 seconds, which makes me think I need to draw a tangent to the graph at 5 seconds. So I'm going to find 5 seconds, take my ruler, I would do it in pencil, but I'll do it in pen so you can see more clearly on the video. And make the tangent as long as possible means you get a more accurate reading. I then need to find the gradient. For gradient I know I need to do y2 minus y1 over x2 minus x1. So I need to work out what are these y2s and x2s by finding the coordinates of these end points. This point has x coordinate 8 and the y coordinate it looks like is, I can see that 10 squares is 40, so each little square is 4, so it looks like that's 64, that's 68, it looks like it's about 66, about halfway between 64 and 68. And then for this point it looks like it's, I can see 10 squares is 2, so each square is 0.2, so that's 2.246, that's 2.8, and the y coordinate is 0. So this is x2, y2, and this is x1, y1. So my gradient is going to be 66 subtract 0 over 8 subtract 2.8. I'm going to type that into my calculator. Get 12.69. They haven't specified a degree of accuracy, so I'll give it to 3SF. You would get full marks for anything in the range 11 to 19. You get 1 mark for drawing a tangent, 1 mark for your process to find the gradient, so this line, and then full marks for an answer between 11 and 19. Question 15. A darts team is going to play a match on Saturday and on Sunday. The probability that the team will win on Saturday is 0.45. If they win on Saturday, if they win on Saturday, the probability that they will win on Sunday is 0.67. If they do not win on Saturday, the probability that they will win on Sunday is 0.35. Complete the probability tree. I know that probabilities add to 1, so I'm going to do 1 subtract 0.45 is 0.55. It says if they win, the probability they will win on Sunday is 0.67, so that must go here. 1 subtract 0.67 is 0.33. It says if they don't win, the probability that they will win is 0.35, so that must go here, and then 1 subtract that, 0.65 must go here. You would get 1 mark for 0.55 in the correct place, and then 1 mark for the rest of the branches. Correct. Part B. Find the probability that the team will win exactly one of the 2 matches. Exactly one means they could win on Saturday and not win on Sunday, or not win on Saturday and win on Sunday. So I'm going to find the probability of each of those. Win on Saturday, not win on Sunday means I'm going along this set of branches, and when I go along the branches I multiply. So I'm going to do 0.45 times 0.33, which is 0.1485. And then the other option, not win, win. So along this branch, not win, and then along this branch, win. When I go along, I multiply, so I'm going to do 0.55 times 0.35. Gives me 0.1985. And then I know it's this, or I'd be going down if I wrote the options at the end. And when that's the case, I add. So I'm going to add those together. Gives me the 0.341. Final answer. You'd get 1 mark for working out one of these, so having one of these multiplications, 1 mark for adding them together, and then full marks for 0.341. Final answer, if you've got it actually in the range 0.34 to 0.341, you'll get full marks. Question 16a. On the grid, draw the graph of x squared plus y squared equals 12.25. I can see this is from my core knowledge. I recognise this as this, which is equation of a circle, so this must be a circle. I know that this thing is r squared, and I also know it's a circle centre at the origin from my core knowledge. Circle centre at the origin, so the centre is going to be the origin, and I'm just going to work out the radius. If r squared equals 12.25, I'm going to square root on both sides to find r, which is 3.5. So it's got centre at the origin, and then it's got a radius of 3.5, so that means it must go through 3.5 on each of the axes. It must pass through 3.5 on each of the axes. So I'm going to mark 3.5, that's 3. 3.5 is going to be 2.5 little boxes between 3 and 4. So here, 3, so here, 3, so here. And then using, we want to draw a circle, we want to draw accurately, so use a compass. If you don't have a compass, just do it freehand, but if you've got a compass, definitely use that. You'll get more likely to get the marks for this and the second part as well. And then place the point at the centre, and drawing a circle that passes through 3.5 on my axes. And we're done. you would get 1 mark for a circle with centre at the origin, but with a different radius, and you would get 2 marks for exactly this, circle centre at the origin, radius 3.5. Part B. Hence, find estimates for the solutions of the simultaneous equations. I know when I've got a graph and the word estimate, I need to use the graph. And if it says hence, then I need to use the previous part of the question. So what do I notice? I notice this is the thing that I've just drawn the graph of, so I've done that. So I think I must need to draw the graph of 2x plus y equals 1. So I'm going to draw the graph of 2x plus y equals 1. There's a few options for this. I could rearrange to make y the subject. Let's go with that. So it would be y equals subtracting 2x, subtracting 2x. I'm going to write the negative 2x first. It's in the form mx plus c. And then I'm going to do a table of values. X, y, I'll just do 3 values. So 0, negative 2 lots of 0 plus 1 is 1, negative 2 lots of 1 plus 1 is negative 1, negative 2 lots of 2 plus 1 is negative 3. I'm going to plot those points, so 0, 1, 1, 1 negative 1, and 2 negative 3. And connect with a straight line. And you just want to make sure that it's long enough that it passes through sort of both points on the circle where they intersect. The solutions to these simultaneous equations are where the two graphs intersect. So these 2 points are going to give me my 2 solutions. I can see these are equations in y and x, so I want the y and the x coordinate. So for this point, the y coordinate, sorry, the x coordinate is, so each little box is worth 0.2, so that's going to be negative 1.2. And the the y coordinate is, looks like it's here, so that's going to be 3.4. And then for this one, the y coordinate looks like it's about negative 2.24689, about negative 2.9. And the x coordinate looks like it's 2. So I'm going to write those as a set of solutions. So I've got that first point. It's going to be x equals negative 1.2, y equals 3.4, making it clear that those two go together. And the second point is x equals 2, y equals negative 2.9, making it clear that those two go together. If you've given them as coordinates, so if you've written this as negative 1.2, 3.4, that's also fine as a way of writing your answers. You would get 1 mark for drawing the graph of y equals 2x minus 1. You would get 1 mark for a pair of x values or y values or a correct xy pair. And you'd get another mark for the second pair, so for both pairs. There is a range because you're using the graph. So it doesn't actually give give the range. So for here I've got 3.4 rather than 3.3, but I would get the mark because it says follow through. So you're just using your graph and check graph for answers. So long as you're using your graph and reading, making it really clear that you're reading from your graph, you'll get full marks. If you're kind of, I would say 0.1 out, that would be fine. Okay. Question 17. The histogram shows information about the times taken by some students to finish a puzzle. Complete the frequency table for this information. I know that to work out frequency, I can remember from my core knowledge, frequency density for a histogram is frequency over class width. So to work out frequency, I do frequency density times class width, or the other way that I know about frequency is it's the area of the bars. So I'm going to find the area of each bar. They've done the first bar for me, so I'm going to go straight to the second bar. The base, or the class width, it's going from 5 to 15, so that's a width of 10, and the height is 0.4, so I'm going to do 10 times 0.4 is 4. The next one is going to be another from 15 to 25, 10 times 0.6 is 6. The next one from 25 to 30 is 5 times by 1 is 5. And then the last one from 30 to 50 is 20 times 0.2 is 4. So I've got 4, 6, 5, 4. You would get 1 mark for any calculation and 1 mark for all of these correct. Part B, find an estimate for the lower quartile of the times taken to finish the puzzle. I know when it's estimate for a graph question, I need to use the graph. I know lower quartile, when the data is grouped, which it is, it's grouped into these class intervals. To find the lower quartile, that's the quarter waypoint, which is going to be n over 4, not n plus 1 over 4, n over 4. So I'm going to work out what's n, first of all, which is going to be the total of these frequencies. So 4 plus 4 plus 6 plus 5 plus 4 is 23. So I need to do 23 over 4 to get the position of the lower quartile, which is 5.75. I then need to work out which class interval is the 5.75th person sitting in, and I do that by counting up. So on the 5.75th person, I'm going to count up until I get to them. So I've got to the 4th person, I've got to the 8th person, I've got to or past 5.75. So in this class interval, which means it's going to be somewhere between 5 and 15. To work out exactly where it is, I know it's somewhere between 5 and 15, I'm going to use linear interpolation, which is where I take the lower bound and then I go how far into that bar divided by the total frequency for that bar, or how many in the bar, times by the class width, so the width of that bar. So the lower bound would be 5 plus how far into. I got to the 4th person, but I wanted to get to the 5.75. Yeah, I wanted to get to the 5.75th person, so from 4 to 5.75 is 1.75. So I want to go 1.75 into. The frequency for that bar is 4, and the class width for that bar is from 5 to 15, 10. So I can now type that into my calculator. Gives me 9.375. You would get 1 mark for 23 over 4, so 5.75, any of this is 1 mark. And then it was only 2 marks, so the second mark is for 9.375. Question 18. ABCDFGH is a cuboid. AB is 7.3. Let's put that information on from A to B. 7.3, that's going to be the same as DC. I'm going to put it there. It's a little bit less cluttered to put it there. CH is 8.1. CH. And angle BCA, so that would be, I'm going to draw in CA so that I can draw angle BCA. So angle BCA means I'm going from B to C to A. It would be this angle is 48 degrees. Find the size of the angle between AH and the plane ABCD. Give your answer to 1 decimal place. First I'm going to do is see if I can identify this angle. And I guess just to say that my angle I'm expecting, let's see if we can identify it first actually, and then we'll think about what we expect it to be. So AH, I'm going to draw that in. And the plane ABCD is this plane in the base of the triangle, so the angle between AH and this plane, I need to draw a line in that plane, and it would actually be this line that I've drawn, so AC. So the angle between AH and the plane ABCD is actually going to be the angle between AH and AC. So it's going to be this angle. Now that I've drawn it in, I can think about what kind of thing I expect, which is that it's going to be less than 90. So somewhere between 0 and 90, maybe like 30 to 70, something like that, is what I expect. I'm now going to draw out this triangle because it's a bit difficult to see when it's embedded inside of the cuboid, so I'm going to draw it out separately and label the vertices, and I'm going to draw it as if I'm looking at it side on. So this is A, this is C, and this is H. I'm going to put any information I know about the triangle, which is, I know HC is 8.1. I also know that this angle is 90 degrees because it's between a vertical and a horizontal plane. So that's going to be 90. And I want to find this angle, theta. I'm thinking about how to find it. I'm thinking SOHCAHTOA because I've got right angle triangle and an angle. And I'm thinking I need another length, and I'm thinking this AC I might be able to find because it looks like it's kind of inside of a few other triangles. So I'm going to see if I can work out AC first of all. To find AC, I can see that it's in this triangle, kind of in the base of the shape. So I'm going to draw that triangle out as if I'm looking down on the shape. So this is D, this is A, this is C, and I'm trying to find AC so that I can work out this angle. So I'm trying to work out this length, AC. I know that this is a right angle because it's part of a, this is a rectangle. If it's all of the faces are rectangles, if it's a cuboid. Be careful, they're not all the same. I can see these two aren't the same. Cuboid, all of the faces are rectangles, but not all the lengths are the same. It's not a cube. So DC I know is 7.3. I know that angle ACB is 48, so this angle is 48, which means that this angle, this is 90 degrees, so this angle would be, they add to 90, this would be 42 degrees. So I've got 7.3, 42, I've got enough information now to find this. I've got the adjacent and the hypotenuse, so I can use K. So I know that cos theta equals adjacent over hypotenuse. I'm going to sub in my values, so cos 42 equals 7.3 over x times by x. X cos 42 equals 7.3, and then divide by cos 42. So x equals 7.3 divided by cos 42. Which is 98 I'm going to do a few more degrees of accuracy. They want the answer to 1 dp, so I'm going to go to 3 dp. 98.231. I was thinking that sounded way too big. It's because I've for some reason typed in 73, 7.3. 9 point, that sounds better, 9.823. I'm now ready to put that information onto this triangle, so this must be 9.823, and now I can find theta. I've got my adjacent and my opposite, so it's going to be TOA, which is tan theta is opposite over adjacent. Subbing in my values, tan theta is 8.1 over 9.823, and then inverse tan on both sides. So inverse tan of 8.1 over, and use arts, so it's exact, gives me 39.508, which to 1 dp would be 39.5. You would get 1 mark for getting up to here. You might have used sine, you might have used triangle ABC, in which case you'd have sine 48 equals 7.3 over AC. You would get 1 mark for a complete process to find AC, so if you got up to this line, 7.3 over cos 42, or 7.3 over sine 48. That is a mark. You would get 1 mark for a complete process to find the angle, so getting up to, actually getting up to here is where you get the mark. And then your fourth and final mark is for 39.5. There's a range, so from 39.5 to 39.51 you'll get the mark. Question 19. Shape S is 1/4 of a solid sphere, centre O. The volume of S is 576 pi. Find the surface area of S. Give your answer correct to 3 significant figures. Show where you're working. I can see they've given me the formula for the volume of the sphere, and it tells me it's 1/4 of a solid sphere. So I think what I can do is make this equal to this, and then maybe I can work out the radius, which will help me to find the surface area, because I can see that I need the radius for the surface area. So if it's 1/4 of a solid sphere, I need to do 1/4 of 4/3 pi r cubed, which is going to be the 4's would cancel, or I'd end up with 4 over 12, which would simplify to 1/3, so I'll end up with 1/3 pi r cubed. That is the volume of 1/4 of a sphere, and that must be equal to this. This is also the volume of this 1/4 of a sphere, 576 pi. I'm going to see if I can solve this to find r. The first thing I notice is they're both multiples of pi, so I can actually cancel a pi on both sides just to neaten it up. So I've got 1/3 r cubed equals 576, I'm now going to get rid of the third by timesing by 3, or dividing by a third, same as timesing by 3, so r cubed equals 1728, and then cube rooting, so r is equal to 12. Nice whole number, that makes me feel good. Now I'm going to see if I can find the surface area. It says the surface area of a sphere is 4 pi r squared, but I've just got a quarter of the surface area of a sphere, because I've just got a quarter of that curved surface, so that is going to be a quarter times 4 pi r squared, which is going to be the quarter and the 4 will cancel, just pi r squared. So this curved surface must be pi r squared. I can then also see that I've got half of pi r squared. This is like a flat face, which is half of a circle, so like a semicircle. So that's going to be a half of pi r squared. And then I've got another flat face here, half of, which is another semicircle, so that would be half of pi r squared. Not a full circle, it's a semicircle. So I'm going to need to add together these 3 faces. So I'm going to have pi r squared plus a half pi r squared plus a half pi r squared, which is going to be, these would add together to be 1 whole pi r squared. So altogether I have got 2 pi r squared. I'm now going to sub in my radius. So we've got 2 pi times 12 squared. They want it to 3SF, so I'm going to type that into my calculator. It gives me 288 pi, but they want it to 3SF, so 904.7, which to 3SF, that's my third significant figure, that would round to 5, so it'd be 905. You would get 1 mark for actually just writing this. A quarter times 4/3 pi r squared is a whole mark. 1 mark for a complete process to find r, so if you got up to this cube rooting. 1 mark for a process to find the curved surface area, so if you've got a quarter times 4 pi r squared, that as well is a whole mark. 1 mark for a process to find the complete surface area, so if you got up to this line, that is a mark. And then full marks for 905. There is a small range, so 904.7 to 905, and actually if you'd written, strangely if you had written it as 288 pi, you'd actually get full marks, even though you haven't written it to 3SF, you'd still get full marks. Question 20. Martin did this question. Rationalise the denominator of 14 over 2 plus root 3. Here's how he answered it. Timesing by 2 minus root 3 over 2 minus root 3. That looks good. I can see it says that Martin's answer is wrong and we need to find his mistake, so I'm going to check each line carefully and see if I can spot any mistake. So timesing out 14 times 2, 28, yep. 14 times negative root 3, negative 14 root 3, that looks good. And then multiplying 2 times 2, 4, 2 root 3, yep. Minus 2 root 3, root 3 times root 3, aha, that's where he's gone wrong. So root 3 times root 3 is 3, but root 3 times negative root 3, he should have written negative 3 there. There's his mistake. So find Martin's mistake. Root 3 times negative root 3 equals negative 3, not 3. Yeah, there's not really many other ways that you'd express that, so that's for 1 mark. Sine did this question, rationalise the denominator. Here's how she answered the question. Sine's answer is wrong, so again I'm going to see if I can find the mistake. Timesing by root 12, that looks good. And then I can see she's simplified root 12. Let's just double check that's right. So root 12 is root 4 times 3. Root 4 times root 3 is 2 root 3. Aha, that's the line that's wrong. Root 12 is 2 root 3, not 3 root 2. So root 12 equals 2 root 3, not 3 root 2. Again, not many other ways you would be able to express that, so that's how you get your mark for that one. 21. Jackson is trying to find the density. As soon as I see that word, I'm going to highlight from my core knowledge. I know density is mass over volume in grams per centimetres cubed, and that also helps me just confirm. So grams is a unit for mass, centimetres cubed unit for volume of a block of wood. The block of wood is in the shape of a cuboid. He measures the length as 13.2, correct to, as soon as I see that, it makes me think of bounds. Correct to the nearest millimetre. Width as 16.0, correct to the nearest millimetre. And height as 21.7, correct to the nearest millimetre. He measures the mass as 1,970, correct to the nearest 5 grams. By considering bounds, work out the density of the wood, give your answer to a suitable degree of accuracy. You must show all your working and give a reason for your final answer. Suitable degree of accuracy, I know that means I need to find the upper bound for the density and the lower bound, and then I decide what they'd both round to. The first thing I'm going to do is see if I can find my upper and lower bounds for these measurements, length, width, height and mass. So for the length, the upper bound is going to be, I like to do it like this, but you might do it as an inequality. The upper bound, if it's correct to the nearest millimetre, 13.2 is, you could write it as 132 millimetres. I know there's 10 millimetres in 1 centimetre. So correct to the nearest millimetre means they've rounded to that 2, where they've actually rounded to 1 dp if we left it in centimetres. So I'm going to leave it in centimetres because I know that they want, Jackson is trying to work out the density in grams per centimetre cubed, but just to confirm they've rounded to that 2. The upper bound is going to be 13.25 and the lower bound would be 13.15. For the width, the upper bound is going to be 16.05, the lower bound is going to be 15.95. You can always use your calculator with all of this. I'm doing 0.1 divided by 2 and adding on and subtracting 0.05 from those measurements. And then for the height, upper bound is going to be 21.75, lower bound is going to be 21.65. Finally, for the mass, the upper bound, I'm going to do this with my calculator. I'm going to do 5 divided by 2 is 2.5, add it on, 1970 plus that, gives me 1972.5, and then subtract 2.5. So 1970 subtract 2.5 is 1967.5. Okay, now I'm ready to think about my calculation. I know for density, the formula is mass divided by volume. I've got my mass, but I haven't got my volume, so I think I need to work out the volume, and I'm going to need to work out the upper bound and the lower bound for the volume. So for the volume, the upper bound is going to be all of these upper bounds times together. So 13.25 times 16.05 times 21.75. Which is 4,625.409375. and the lower bound is going to be all the lower bounds times together, so 13.15 times 15.95 times 21.65. Oops, 13. Good, I've got a number that's not miles away from this, but it's less than. I'm expecting that because it's the lower bound, 4,540.925125. I am going to write all the digits because for these types of questions, it is all about accuracy. So I'm just going to, it's a bit annoying, but I'm going to write all of those digits down. Okay, now I'm ready to think about my calculation for density. I know density is mass over volume. To find the upper bound, I would need to do the upper bound for mass divided by the lower bound for volume. So I'm going to take the upper bound for mass and divide that by the lower bound for volume, which is this one I just worked out. Which gives me 0.43438. And then to find the lower bound, I would need to do the lower bound divided by the upper bound, which is going to be the lower bound for mass, so that's 1967.5, divided by the upper bound for volume, so that's the 4625 number, which gives me 0.42539. I'm happy because these numbers are kind of close. If I got two numbers that were wildly different, then I'd maybe kind of not written in one of the numbers right. And I'm also happy because the upper bound is bigger than the lower bound. I'm now ready to move to deciding what would they both round to. So I'm going to write them on top of each other. So I've got 0.43438 and 0.42539. I want them to both round to the same thing. I can see they'd both round to 0.4, but I'm going to try and go a bit more accurate. Let's go to 2dp. This would round to 0.43, and this would round to, oh, that would also round to 0.43. Let's see if we went any more. No, this would be 0.434, this would be 0.425, are different. So my final answer is going to be 0.43 grams per centimetre cubed, and my reason is as both upper bound, lower bound round to this. And actually, sorry, I should have one extra thing, which is the degree of accuracy. So 0.43 correct to 2 decimal places, or it could be 2 significant figures. You don't need to write both, but if you've written one of those, that's perfect. As both upper bound and lower bound round to this. Okay, that was 5 marks. You would get 1 mark for a correct bound for any lengths or masses. So just one of these values gets you a whole mark. You'd get 1 mark for a correct calculation for your volume. So this gets you a mark. You would get 1 mark for a correct calculation for density. So this is a mark. You would get 1 mark for having both of these values. And then your final mark is 0.43 to 2dp or 2SF as both upper bound and lower bound round to this. You must have 0.43. You don't actually need the units. You must have either 2dp or 2SF, and you must have as both upper bound and lower bound round to this to get that 5th and final mark. That's the end of the paper. I hope that you did well.